These are notes 2.3, motion and forces. So a force is just a push or a pull that one exerts on another. Okay, so it's measured in newtons, and it is the symbol for it is just a capital N. Okay, so force is the transfer of energy to an object. So force also causes the motion of the object to change. Okay, so if you were to push on a box, you're transferring your energy to the box, and that can cause the box to move. Okay, so starting, stopping, and changing direction is caused by an unbalanced force. Okay, so if you, for example, have that box, if we put an unbalanced force on that object, it's going to start moving. Or if there's a moving object, say someone threw a ball at you, it's moving through the air. If you catch the ball, you're stopping the motion. Okay, so you are exerting a push back on that object to make it stop, or you can change the direction of an object. So if you have a soccer ball rolling towards you, you can kick it with an unbalanced force in order to change its direction. Okay, so it does not always change the velocity of the object. Okay, so if there's a force acting upon an object, it can be balanced forces. And so a balanced force, we're going to have a net force of 0. Okay, so if you look at this picture, we have two people pushing on a box. Okay, they're equally pushing with the exact same force, so there's no movement in the box. Okay, or like in the example above in the unbalanced forces, if we were playing tug of war and our balances or our forces, our pull forces were equal, the rope isn't going to move. Okay, so an unbalanced force is going to cause some kind of change in the motion, but balanced forces is not going to cause a change in the motion. Okay, we have these practice vectors. So a vector is just an arrow that helps to show the force exerted by an object. Okay, so the first one, we have 8 newtons to the right and 5 newtons to the right. And for this one, 8 plus 5 would be 13 newtons. And I forgot to put the direction. It should have been to the right. Okay, for the next one, we have 8 newtons, but it's to the left, and then 5 newtons to the right. So since they're in opposite directions, they're going to subtract from each other. So 8 minus 5 newtons gives us 3 newtons, and because 8 to the left is bigger, it means the motion is going to be to the left. So 3 newtons to the left is our net force. Okay, and then our last one, we have 3 newtons to the right, 10 to the left. Okay, because they're in opposite directions, we're going to subtract. So I'm going to go ahead and just do my largest one first. So 10 newtons minus 3 newtons will give us 7. And because our larger arrow, our larger force is 10 newtons to the left, it means our net is going to be 7 newtons to the left. Okay, so with force, there's this thing called inertia. Okay, so inertia is just the tendency of an object to resist any change in its motion. Okay, so I like to think of myself having lots of inertia whenever it's time to get out of bed. Okay, I resist the change in motion to actually get up out of bed. Okay, so a greater force is needed to change motion of an object with a larger mass. It's going to have greater inertia. Okay, so if you think about pushing a shopping cart, you don't have to put as much force as if you were trying to push a car. Okay, and the reason for that is because they have different masses. So an object that has more mass is going to have more inertia. Okay, if let's say you're a football player, okay, you have a 5-year-old come and try and tackle you, you're not going to experience as much force as if a grown man comes and tackles you. Okay, so the amount of inertia or the amount of force that an object can cause is based on their mass. Okay, so Newton's first law of motion And we'll kind of get into a bit more of Newton's laws here in a little bit. But Newton's first law is also known as the law of inertia, but it's applied to all objects you encounter every day. So the law is an object at rest will remain at rest, and an object in motion will remain in motion until acted upon by an outside force. Okay, so this force just has to be unbalanced. Okay, so if you have, let's say on the desk, there's an apple sitting on the desk. The apple will remain sitting on that desk until some force comes and moves the apple. Okay, such as me picking it up, me pushing it over, maybe there's a wind that comes by. That would be a force that's unbalanced. Okay. All right, so think about in a car accident or collision, why would a seatbelt be important in terms of inertia? Okay, so you might have experienced this before, but whenever you're riding along in the car and all of a sudden, let's say your mom is driving and she slams on the brakes because someone in front of her pulls out. Okay, so whenever she slams on the brakes, you probably have experienced this, that your body continues to go forward. And your mom probably did the mom arm where she stuck her arm out to catch you, okay? So the seatbelt is there to be your mom arm. Whenever there is that quick change in motion of the car, your body is experiencing inertia. So it's still continuing in that same path. It's not going to stop at the same rate as the car, especially you feel it more so whenever it stops quickly. Okay, so if there was nothing to stop you, you would continue forward. Okay, so if you don't have a seatbelt, that's why a lot of people who aren't wearing seatbelts and they're in a collision, they can actually be thrown from the car because their body still has inertia of that original motion, and they're going to continue forward if they're not stopped by something such as a seatbelt.